Howdy, folks. Welcome to lecture 4.5, a continuation on matching. And for today's lecture, we will have an introduction to enums, and we will explore some special enums, specifically result with two variants, okay and here, and option with two variants, some and none. And we will also explore control flow with enums and match. So let's do a quick refresher on match. They are expressions that allow you to compare value against a series of patterns and execute code accordingly. And remember, the patterns can be literals, wildcard names, variable names, wildcards, and more. And they must be exhaustive. That means you must check all possible values. And on the right is the example of a match statement we saw from the earlier lecture. And let's dive into enums. So suppose we want to model the days of the week. So for this problem, we have a defined and restricted set of values. Specifically, we have 7 values for 7 days of the week. So how should we represent it? We can have integers. Specifically, we assign 1 to 7 for each day of the week. But what if our program takes user input and the input something like 10? Or we can do strings. Just do verbatim Monday, Tuesday, Wednesday for each days of the week. But then what if the user inputs something like Monday? So a typo of Monday. How do we handle these errors? We throw errors? Do we crash the program? Something like that. So another solution is to just make these errors impossible to occur. We force the type into a very restrictive set of values. And that's where enums come in. So what are enums? They are basically custom types with restricted set of values, as we saw from earlier. These can be used to represent days of the week. So 7 values, or undergraduate student level with 4 values, or colors of the rainbow with 7 values. Here you can see an example of an enum. We have enum day of week with 7 possible values, Monday to Sunday. And we also see an example of how to declare an enum. So we just let variable today equal to day of week. So that's the name of the enum, colon Saturday. That is the value. Each of these value, Monday, Tuesday, Wednesday, etc., is called a variant. So the variable today we see here is of the variant Saturday of the enum days of week. We can do matching on enums like integers or LCNSTR. Enum variants are also patterns. So each of the variants, Monday, Tuesday, Wednesday, are patterns. We can do match on enums accordingly. Here you can see a match statement on enum. Here you see we especially have cases for the pattern Monday, where we will print like, that's Monday, right? And we also check for patterns Saturday and Sunday, where we will print like, yay, weekend, because it's weekend. And for all the other days, we just print like weekday, because they have nothing special. And again, patterns must be exhaustive. That means for when we match on an enum, we must consider all variants. Let's look at an example. So here you can see basically the same example from a similar example to the one from the lecture slides. Here we see another of enums where we have 2 elements. The first element is of the Monday variant. The second element is of the Tuesday variant, and the last element is of the Saturday variant. And we iterate through the array, and for each element we do a match, and using basically the same logic as we saw in the lecture. We have special cases for Monday and Saturday and Sunday, and for all other cases we just print weekday. So let's see what this program actually look like, actually print out. So as you can see here, it basically prints out what we expected. So for the element Monday, it prints out Monday. Ugh. And for the element Tuesday, for the element of variant Tuesday, it prints out weekday. And for the variant Sunday, it prints out this J. And that's in addition to enum and how to match on it. So what if we also want to model the number of classes we take on each day of the week? Enums also allow us to do that. So enums in Rust can also contain values. As you can see here, each of the 5 variants from Monday to Friday contain a value of type I32. Whereas the variants Saturday and Sunday don't contain any values because we don't have classes there. And how to declare a enum containing a value? So it's very similar to the syntax from earlier. We just do equal to day of week, colon, the variant, and then we put parentheses with a value inside of that. And the values of the variants are also patterns. Again, patterns must be exhaustive. That means you also have to check all values of the values of the pattern too. And matching is the most common way to extract values from an enum variable. And since patterns must be exhaustive, to extract values, we need to consider all possible patterns. As you can see here, is an example of how to match on an enum containing values. So the first match arm here, we see the variable syntax where we basically check for all variants contain of the type Monday, and we don't care about the inner value. We just assign them to the value num classes, and then we print that out. For Tuesday, we have some special cases here. We consider the case where we have a variant Tuesday containing the value 3. We also consider the case where it contains the value 4. And we have a case for all other values. And as similar from earlier, we have the cases for Saturday and Sunday, and a wildcard for all other cases. This wildcard can include cases like Tuesday containing, no, not Tuesday. Tuesday, we already checked all Tuesday. We can have cases like Wednesday containing 1, Wednesday containing 2, 3, 4, 5, and the same for Thursday and Friday. And let's look at an actual example. So here you can see again a similar example to the one from the lecture. Here we have an array of 4 variables all from the enum day of week. The first one is of the variant Monday containing the value 4. The second and third one are of the variant Tuesday containing the values 3 and 5. And the last one is of the variant Saturday, no values because we don't have values for that. And again, we do match on each element. And here you can see basically the same logic. We check for Monday, and we basically check for accept any values of the variant Monday. And here we have a special case for the variant Tuesday containing the value 3, and a case for the variant Tuesday containing other values, and a special case for Saturday and Sunday, and another one for everything else. So let's print this out and see what happens. As expected here for each possible values, the first one is a Monday, so it prints out the Monday and the number of classes as per this print here. The second one is the special case Tuesday containing 3, so it prints out this string. I have 3 classes on Tuesday containing 2 args corresponding to this match arm. And the third element is Tuesday containing 5. It's not 3, so it belongs to this case. And for here, we print out this string here. And it's the same string, as you can see. The last one is Saturday. So it prints out the weekend. Now, let me introduce you to a special enum. So you may be familiar with pointers from languages like Java or C++. A pointer can either be a valid pointer, so it points to an address of an actual object, or a null pointer, meaning it doesn't point to anything. When using pointers, developer must always remember to check if the pointer is null. This oftentimes very hard, and you may also make mistakes where you forget to check and end up with a null pointer dereferencing. So what if we have a type that forces us to perform this check? The check if the pointer is of the variant valid or invalid or no. So what does this sound familiar to? Now, enums and pattern matching. So the option is a special built-in enum representing an optional value. It has variance sum, meaning it contains a value, or none, meaning it contains no value. So think weekday versus weekend variance from the day of week enum. The weekday variance contain actual values and weekend contains no value. They are basically used for functions that are not defined over the entire input range. So as you can see from this example here, this match statement, we don't have logic for it for values other than these four values here. So only for these four values here, we return a sum variant, and for other values, we return a none. It's similar from the example from the March lecture, except we use an option to represent it. Do note here that we don't need to do option colon sum or option colon none, as opposed to the enums that we define ourselves. Because this enum, the option enum is built into the language. And let's look at an example. So here you can see our getProf function that takes in a cost number and do that logic we see from the lecture. For if the cost number is one of these four values, then we return the sum, and that sum variant contains a professor name. And for all other numbers, we return a none, meaning that we don't consider them. And in the main function, we have an array named courses of 6 values, 4 of which are corresponding to these 4 here. And the other 2 are the classes 233 and 341. Again, we iterate through the array. And for each of the course numbers, we call the function getProfessor, and pass in the course number. And then we do a check if the professor name is a none, that means it's in this case here, we print out I don't know who teaches this CS class. And if it's a sum, it's some variant, that means one of these 4 cases here. We print out the professor name and the class number. So let's try running it. As you can see here, the results are what we expect. So for the first 4 values that correspond to these 4 cases, the program prints out the professor name and the class number. And the last 2 classes here, we don't consider them, so they belong in the none case. And the program correctly prints out, I don't know who teaches this class. And now for another special enum. You may remember exceptions from C++. That's used for operations where failure can occur, and then we just throw in exceptions, and then the caller of our function need to catch the exceptions. Then again, the caller needs to remember to catch exceptions. They may forget to do it, and bad things may happen. Then again, what if we have a type that forces it to catch these failures? So similar to the null pointer example from earlier. And enums again help us here. Just like option, enums are special built-in. Just like option, the result is a special built-in enum representing fallible operations with two variants. The OK variant representing a successful operation, and it contains the operation's value. So the T you see inside the variant. And the error variant representing a failed operation, it contains a value indicating the error. So the that E value inside the error variant. A function may return the result if failure is expected and recoverable. So you expect the function to encounter failures from time to time, and you want to account for that case. So that's like exceptions. In the ROT standard library, the result type is most commonly used for IO. If we have no meaningful value for T and E, so we just want to perform an operation and we don't expect it to return any value, we use a unit type as a placeholder. And let's look at an example. So here you have a function divide that taking two integers and returns a result type. Where the OK variant, this is a syntax for how you declare a resulting num. We have an integer for the representing the value for the OK variant, and a division arrow that is another enum that we declared represent for as a value for the air operation. The division arrow enum here has two variants with no values. Division divides by 0 variant and the truncation arrow variant. So what does this function do? So if b the meaning the denominator is 0, we return an arrow variant containing the divide by 0 variance of this enum. So as you can see, we kind of have a nested enum here. We have a result enum where the arrow variant is again this enum, and then we have to consider this the variance of this enum we create. This is a very common pattern for the result enum, and it may get some time to get used to. It might take some time to get used to. And for second case, if A is smaller than B, we return an arrow variant because our division may fail. And the truncation arrow and an enum value, the truncation arrow variant from this arrow type we declare here. And otherwise, we just divide A by B and put that into an OK variant. For the main function, we again have an array containing 4 tuples, 4 pairs of number. And for each pair in this array, we first call divide on the pair and then we match on the result. Because this function returns a result enum. If the variable is of the OK variant, then we just print out the value of the division. If it's of the divide by 0, if it's of the arrow variant and the arrow type is divide by 0, we print out denominator is 0. And if it's of the arrow type and the arrow type is truncation arrow, we prints out result will be truncated to 0. So yeah, we have a nested enum here where we basically have several variants for an arrow because for fallible operations, the operation may fail in different ways. So oftentimes we have an enum for different error cases. It's like it's basically like a tree where the arrow node has children that are again different variants of the same enum. And let's actually run the program and see what it prints out. As you can see here, for the first two values, they are valid. So the program prints out the result of the division. For second value, A is smaller than B, so it prints out result will get truncated to 0. And for the last value, B is 0, the denominator is 0, so it prints out accordingly. Here are some useful methods you may use on an option or a result. The first are is_sum and is_OK. These two functions check if the option that is for is_sum, because option has a variant sum, or the result that is is_OK, because result has an OK variant. It checks if these enums, if these values represent successful operations. Successful, that's a keyword here. And the other two functions is_none and is_err. They are the opposites of the above functions. These check if the option and or result represents failed operations. We also have the function unwrapped, or this function extracts the value from the successful operation, or otherwise returns a default, that is a value t we will pass into the function here. And you can call this on both option and result. Here are some other functions that are sometimes used. These are very dangerous. You should use these with caution or just avoid them at all if possible. Where's the function expect? And it takes a message that is an underscore an $str. Use this one when we are 100% sure the operation succeeded. So this gives us a success value. This option will cause the program to panic, basically crash, if the operation failed and print out a message as a crash message. And then we have the function ungrab that does the same thing as expect, except it doesn't print out anything when the program crash. So they're very similar in that. And that's basically it. That's an introduction on enum and some special enum types.